Okay, so for these problems, you always are supposed to try direct substitution first. So like if I do that here, I'm going to have 0 plus 1, or square root of 0 plus 1 minus 1 over 0, which will give me square root of 1 minus 1 over 0. What is the square root of 1? It's 1. 1 minus 1 is 0. Got a 0 on the bottom. See how I used the arrow right here instead? I'm getting 0 over 0. So that doesn't tell me anything except for I need to keep working, right? So that means I need a different method. So I'm going to rewrite this here since I've kind of messed up the amount of room I have to work here. And we'll switch colors. Okay, so whenever you have a problem that has a square root and you're getting 0 over 0, there is a decent chance that you need to rationalize the numerator or denominator. It really doesn't matter which one it is. If you have a numerator with a square root, rationalize the numerator. If you have a denominator with a square root, rationalize the denominator. Just try to get the square root to the other side. Okay? So to do that, most of the ones that we're going to see are going to be cases like that third example we did on the warm-up, where we've got a plus or a minus sign there. So we have to multiply by the conjugate here. Let's write that down. Let's write down that phrase. So whenever you guys go to college and you get a super genius professor and they say multiply by the conjugate, you're like, I know what that means because I am also a genius, instead of thinking I've never heard that word in my life. So, we're going to multiply by the conjugate. For the conjugate, the only thing that you change right here is this middle sign. Don't change what's under the square root. Don't change the last number, just that middle sign. So it will look like this. Looks a little complicated, but it looks like this. You're going to have square root of x plus 1. You might be tempted to try to make that x minus 1. Don't. Leave it alone. The minus right here changes to a plus, and then you have a 1 here. And don't forget, if you have that in the numerator, you must also multiply by that same thing in the denominator. It's really easy to forget to write that down here. Okay, questions so far? Okay, now over to the side here, I'm going to multiply this out. It's going to be like the same thing happening every time. The middle terms cancel out. Eventually, you hopefully might be able to just kind of like do this in your head. But for right now, I think we probably need to see it multiplied out to understand what's happening here. So over to the side, I'm going to work this top part out. When I multiply square root of x plus 1 minus 1 times square root of x plus 1 minus plus 1. So we got square root of x plus 1 minus 1 and square root of x plus 1 plus 1. So we have to multiply first terms. Square root of x plus 1 times square root of x plus 1. What does that give us? Just x plus 1 with no square root, because you're basically squaring a square root, and that cancels each other out. Then I shall multiply here square root of x plus 1 times positive 1. That's just going to give me positive 1 times square root of x plus 1. We don't have to write that 1 out front, but you could if you wanted. If it was a 7, we'd have 7 here. Then we got to do our inner terms, and that's going to give me minus square root of x plus 1. And then our last terms, negative 1 times positive 1 gives me negative 1. And so we're choosing the conjugate because this happens every time right here. If you chose the conjugate correctly, the middle terms cancel out. And those middle terms were your square root terms, right? So in this particular case, that just leaves us with x plus 1 minus 1. And what happens with our plus 1 and our minus 1? Also cancel out, and we just get an x, right? So it's kind of crazy, right? All of that mess simplified all the way down to x. That's what we were doing when we multiplied these two right here together. So when we rewrite our limit as x approaches 0 is going to be of that numerator. When we multiplied all that crazy stuff together, all we got was an x. In our denominator, don't multiply your denominator together, because your point is you want something to cancel, and if you multiply it together, you're just going to have to factor it back out. So don't multiply the denominator together. Write it like this: x times square root of x plus 1 plus 1. And hopefully you can kind of see why I do not want to, I don't want to multiply that x, because now what can cancel? The x on top and bottom, right? So the x on top and bottom cancel. You have to have something still on the top. What was in front of that x but was invisible? A 1. So put it back up there so you don't mess up. A lot of kids just get rid of the fraction altogether and put it in the numerator, which would be incorrect. So we're looking at the limit as x approaches 0 of 1 over square root of x plus 1 plus 1. Usually when that cancels, most of the time, you're now to the point that you can do direct substitution. And you can right here. So we got 1 over square root of 0 plus 1 plus 1, which is going to be 1 over square root of 1 plus 1. What is the square root of 1? It is 1. So this is just 1 over 2. And 1/2 is our answer. We okay here? It's a little lengthy. It's a little complicated as far as dealing with all those square roots. But if you're just like systematic about it and following those steps, being careful with your multiplying, it should work out for you. Let's try another one. Okay, this one has square roots in the denominator. So in this case, we're going to want to multiply, or we want to rationalize the denominator. It's also a little different because I have a square root here and a square root here. Like I got double square roots in this one, so it's a little more complicated. I should check direct substitution every time. If I plug in 0 here, I'll obviously get a 0 in the numerator. If I plug in 0 here, I get square root of 5 minus square root of 5, also 0, right? So you're getting 0 over 0. Be careful, because every once in a while they'll throw one that's really a direct substitution problem in there. You get 0 over 2, and your answer is 0, right? Or you get 7 over 5, that's your answer. But this one is definitely one where we're going to have to rationalize. So we need to multiply by the conjugate of this stuff. Who can tell me what the conjugate of square root of 5 plus y minus square root of 5 is? We're just changing this minus right here to a plus. So square root of 5 plus y stays the same. We put a plus sign right here. Square root of 5 right here. And whatever we multiply by in the denominator, we have to multiply by that same thing in the numerator. So we're also multiplying by square root of 5 plus y plus the square root of 5 in the numerator. Everybody good here? All right, so I'm going to do the same thing I did before. When you get really good, you're going to be able to do this in your head, and you're not going to have to write this whole thing out, but I don't know that we're there yet since we just have learned about this today. So we got to multiply the denominators together. I'm going to do this sort of over to the side. And I forgot a square root right here. So when I multiply square root of 5 plus y times square root of 5 plus y, what do I get? 5 plus y. Okay. Then, oh gosh, I don't even like thinking of it. But it's okay, because what's going to happen to the middle terms right here? They're going to cancel, right? So don't get worked up about what they are. In fact, like, I usually don't write this out. I usually skip those two because I have done a lot of these and feel pretty comfortable with them. But we're multiplying 5, or square root of 5 plus y times positive square root of 5. Both of those are under the square root, so we could multiply them together. And we would get square root of 25 plus 5y. You would kind of have to like distribute that 5. Again, don't get worked up about it. You could also just write it as square root of 5 times square root of 5 plus y. Because what should happen here is you get negative the same thing. 25 plus 5y. There. Right? And then your last thing you've got to do is you're multiplying negative square root of 5 times positive square root of 5. Square root of 5 times square root of 5 is just 5. One of them is negative, one of them is positive. So you get a minus 5 right here. And the reason we choose the conjugate every time is because it should make those middle terms cancel out. Right? So if you don't even want to write it down, that's fine. I usually don't. That leaves you with 5 plus y minus 5. And 5 plus y minus 5 is just y. You will find that a lot of times it just ends up being the variable. There are some exceptions to that, so I don't want to say every time, but a lot of the problems you're going to, when you multiply by the conjugate, you just end up with a variable left. So if we go back over here to our problem, we got limit as y approaches 0 of, in the numerator, we got y times square root of 5 plus y plus the square root of 5 over, in the denominator, when I multiplied all that stuff together over to the side, all I got was y. Okay, questions? All right, we're going to cancel those right there. We're going to get the limit as y approaches 0 of the square root of 5 plus y plus the square root of 5. Now, I did do away with the denominator here, because if I put the 1 right here in the bottom, dividing by 1 doesn't change anything. I don't have to keep that as a fraction. It's only when it's in the numerator that matters. And so now I'm going to try direct substitution. Square root of 5 plus 0 plus the square root of 5. That's going to be the square root of 5 plus the square root of 5. What is that? It is 2 times the square root of 5, because each one of these have like a 1 in front of them. It's like adding 1x and 1x together, you would get 2x. 1 square root of 5 plus 1 square root of 5 gives you 2 square root of 5. And that would be your answer for the problem. Okay, I feel like before we go over to the other notes, we should try, you guys should try 1 or 2 of these on your own. So go to your textbook and try on page 84. Try number 57, and if you get time, do 60. So try 57 and 60. We're going to try a couple of those, and then we'll do our last part of our notes. or well, the other part of our maths. Body's favorites, complex fractions, when we got fractions inside of fractions, always a crowd pleaser. Then we are going to look at some examples where we have a couple variables and we got to expand and simplify. Still fractions, good fun right here. Don't want to leave those out. And then we are probably, these are the two that aren't printed for you. We need to do some with exponentials. I doubt we'll get to those problems because as you can imagine, by the look of some of these problems, they take a little while, right? So we probably won't get to those last two, but that's all right. I'll discount your homework a little bit tonight. We'll probably have to cut a few off. It's like when you go to Belk's and it tells you like this shirt is $65, but everything at Belk's is always like 40% off or something, and then it's really only 30 or whatever it is. So sometimes my homework ends up like that because we don't get through the things that I need to get through. So complex fractions. If I do direct substitution, because that's what I'm supposed to try every time, first time, right? And they'll get you because they'll throw one in that's direct substitution, and you'll forget to check, and then you won't know how to do the problem. But if I tried direct substitution here, I would get 1 over 0 plus 2 minus 1/2 all over 0, which is going to be 1/2 minus 1/2 over 0, which is, in fact, 0 over 0. So, again, indeterminate form is never your answer. It tells you got to do something else, right? So, for complex fractions, what we want to do is try to combine, combine those fractions together and simplify it into a single fraction so that we don't have like a fraction within a fraction. So if I want, there's a couple ways that you can deal with it. I like combining the two fractions up here in the top, getting common denominators and putting those together. So to subtract two fractions, I would have to have common denominators. And, let's think of an easier example, like if I have 2/3 minus 4/5, right? What number would I use for my common denominator? 15, and how do you get 15? Multiply the 3 and the 5 together, right? Sometimes there might be ones where, like, if you got a 2 here and a 6 here, you could use like a number where they sort of overlap, but it'll always work to multiply your denominators together. It might not be the least common denominator. It might not be the easiest way to do the problem, but it'll always work just to like multiply those denominators together. In general, for these problems, you usually just want to multiply the denominators together. So, like this has a x plus 2, and this just has a 2. So to get common denominators, I need to take this fraction, and I need to multiply by 2 on top and bottom. And I need to take the second fraction, and I need to multiply by x plus 2 on top and bottom. And so we're going to be not lazy. We're going to write our limit notation. That's going to give me 2 over 2 times x plus 2 minus x plus 2 over 2 times x plus 2 all over x. Also, don't be lazy and leave off that x right there, because you're doing all your work on the top of this fraction right now, but keep the x in every step until you get to the end. You risk what they call a linkage error, where like if I leave off that x for several steps and I'm putting equal signs in between, I'm saying that what was up here equals this, equals this, equals this. But if I don't have the x in the bottom, that's not true. They don't really equal. So in some cases, they can count points off for that. It just depends on how the rubric is for those. When I put these together, since in the numerator I've got the same denominator, I can put those two together where they just both have 2 times x plus 2 right here. To do that, be really careful. This negative gets distributed to both of those terms right there. So I'm going to have 2 minus x minus 2 right there. That is the stuff in the numerator. I still have the x on the bottom. Also, what have I done wrong? I left off that limit notation. I was being lazy. Right there. No. Because the 2 right here is separate. Well, actually, no. Possibly. Which 2's are you talking about? Yes, you can cancel those out. Sorry, I was thinking you were saying to cancel like a 2 with the 2 in the denominator. Can't do that. But yes, this 2 is positive, this 2 is negative, so these 2's can cancel. So now we've got the limit as x approaches 0 of negative x over 2 times x plus 2 over x. Now we still have a complex fraction here, but we at least have a single fraction over something here. So when we have a complex fraction where we've got a fraction over, the bottom was not a fraction, but I can treat it like a fraction, right, by just putting it over 1. What do I do when I have fractions divided by fractions? Flip the second, multiply. So I'm going to go around here, and I'm going to say the limit as x approaches 0 of negative x over 2 times x plus 2 times 1 over x right here. And so since these two fractions are being multiplied, what can happen with my x's right here? Got one on top, one on bottom, so I can cancel those out. Be careful not to cancel the negative on the top. It's still there, right? Because it's only the x that's canceling. So like this is a negative 1 right there. So this will give me the limit as x approaches 0 of negative 1 over 2 times x plus 2. And usually when the variable cancels out, that is when you can do direct substitution. You could, and in this particular case, it won't make a difference. I generally don't usually distribute because occasionally, like, something's going to cancel and you're going to have to factor it back out anyway. So you could, there's not really any benefit to doing it, but you could. And then so we'll get negative 1 over 2 times 0 plus 2, which is negative 1 over 2 times 2, which is negative 1/4. There. That's some good fun right there. It looks pretty fancy. These are some of those good ones to take home to your moms and dads and be like, look what I'm working on. Like, oh, my baby's a genius, you know. You're so smart. Because starts to get looking a little impressive. Just wait till we do those ones with the E's and you got more letters than you got numbers, and I like those. You look like in a movie whenever the genius is writing everything on the whiteboard, like you look like that. In movies, I always want to like pause it and look and see if I understand any of it, or if it's gibberish or. Okay, next one. Similar problem. Try it on your own. check and make sure I'll get the same answer as me to make sure I did that right. That was a lot of steps. Yes, you're on the right track. Other than that, it looks good. Try simplifying the numerator to see if anything like yeah, and that can simplify anyway. Right, yeah, they'll accept. Well, actually, 12 will probably be wrong. Every 25 over 2. Oh, if you one over 2. That's what I was talking about, which is first anyway. So you would just want to leave it, but they'll take decimal fractions as long as they're correct to 3 decimal places. No, because of like the -3. But this and this are related, right? What could we do to this so that we could get like x -3? Yeah, so like if we factor out a 2, it's going to come back down. And we'll be able to cancel something because we can cancel that whole expression. It's right here. Those cannot cancel because of this -10 right here. And your -10 kind of disappears. Yeah, as well. Yeah, but these cannot cancel. But I think you're good really up to this point. Try like distributing your 2 and messing with that numerator and seeing if maybe you can get it to cancel something in the denominator. Where did I mess up that? You never really cancel anything out. No, I don't think it is. The only reason you didn't get 0 to 0 is because you made some mistakes, like if you're multiplying, like particularly right here, that's what we got it. Right here. Nothing really ever cancels. So, in general, like, unless you can get something with variable cancel, you're probably just going to get 0 and 0. So, go back. Go back to here. You're fine to here. Okay, thank you. Is that right? You're fine to here. Oh, no, you're not. You're almost okay to here. This right here is x -3 over 1. So when you flip and multiply, it's going to be 1 over x -3. So that x -3 right there should be the denominator. Okay, so go back to that and then think about how you might get something. Yes, but your like limit notation is bad. You won't limit all the way up here till you start limiting this number. And then you don't put the limit. So other than your limit notation, go right. I'll show you what mine looks like when they're right. Almost. Like it can't get to the way that it's right now. But how are like x -3 All right. Oh. Okay. You should get 2 over 25. There is a chance some of your work looks a little bit different than my work because you may have done this in a little bit different steps, but you should have the general same thing happening here. You are going to multiply by x plus 2 over x plus 2 here. We'll multiply by 5 over 5 right here. Most everybody looks like they were doing that right. It gives you this right here. Distribute this 2. It'll give you 2x plus 4 minus 10. That gives you 2x minus 6. Right? Then, I from here flipped and multiplied. Some of you flipped and multiplied earlier. Some of you flipped and multiplied like later. As long as you at some point flip and multiply here, you'll be okay. So I'm getting this. And right here is where a lot of people were starting to fall apart because nothing cancels. But x minus 3 and 2x minus 6 are related, right? If I double this, I would get this. So I can factor out a 2 right here. And so that'll give me 2 times x minus 3 over 5x plus 2 times 1 over x minus 3. Now my x minus 3's can cancel right there, leaving me with this. Plug in your 3. 2 over 5 times 5 is 2 over 25. Okay? So, since we really did not get very far today, your homework assignment, I know you'll be disappointed about this, is from page 84. And you guys are going to do 61 and 62. Those are the only ones we are going to be able to do right now.